Alright guys, so this is the fundamental theorem of calculus part 2 continued. So this is following the examples that we did on 62. So this graph right here is the graph of function f. Okay, so and notice that g of x is the antiderivative of f of t. So what we're going to do on this one is we're actually going to take the integral between 2 and negative 3. Again, I'm just plugging a negative 3 into this x. Alright, that's what I'm doing right now. So we have the antiderivative of f of t dt. Alright, now when you have this, now if you actually had a function here, I don't think it would affect it, but because I have to rely on the geometric figures here, what I'm going to do from here on this problem is that notice that this upper bound, this number is smaller than this number, right? So anytime your upper bound is smaller than your lower bound, what you need to do is you need to switch this around, alright, where you have your lower bound being the smaller number and your upper bound being the bigger number. And remember that this, what I'm writing right here, that actually came from from lesson, I believe, 60. Okay, so you can do that. Now what's going to happen here is that notice that for me to take the antiderivative of this, that's the same thing as me taking the area under the curve, which in this case is the area of this triangle right here. I have to go between negative 3 and 2, so negative 3 and 2 is all the way over here. So the area of that triangle, negative, notice this is going to be negative, plus the area of this triangle right here. Okay, so notice that the area of this triangle right here is going to be 1/2. The base is 4. The height is going to be negative 3 plus 1/2. The base of this one is 1. The height is 3. Okay. Now when we do the math there, it gives us the answer is either 4.5 or 9/2, whichever one you want to use. That's the answer for that. Okay, now on the next one it says that it wants to find the instantaneous rate of change of g. When you see that word instantaneous rate of change, or those words, that's the same thing as the instantaneous rate of change at 4 is the same thing as the derivative of g at 4. Okay, now if you remember from your previous lesson, alright, the derivative, this right here, if this is f of t and this is g of x, that must mean that this was g prime of t, which means in this case that this and f of 4 is the same value. Alright, so all we have to do very easily, we'll just go to 4, x is equal to 4, 1, 2, 3, 4, and we're going to see what the y value is, which in this case it looks like it's 3. Alright, so the instantaneous rate of change at x is equal to 4 is 3. Now write the equation for the line tangent to the graph of f at x is equal to 4. So just like before, we need a point. We need a point and a slope to write the equation of the tangent line. So our point, in this case, it gives us the 4. Okay, and now this is g of 4. Now, unfortunately for us, we don't have that yet. Alright, so we're going to have to find g of 4. So g of 4 is equal to the antiderivative, or the integral between 2 and 4 of f of t dt. Alright, and let's see, between 2 and 4. Now between 2 and 4, let's see, I'm going to use a different color so you can see it. See, that's 2, 3, 4. So this is the area of this, I don't know what you call it. Okay, that's the area of that right there. Now if you look at it, that looks like 2 trapezoids. Okay, where this is base 1, this is base 2, and the height would be 1. So you have 2 of those. So the next thing I'm going to do here is I'm going to write 2 times, and I'm going to write the area, the formula for the area of a trapezoid. Again, this is base 1, this is base 2, and the height is 1, and I have two of those trapezoids back to back. Okay, so I have 1/2 6 plus 3, that's base 1 or base 2, doesn't matter. That's one of the bases, that's the other base, times the height is 1, and that gives me that's equal to 9. Okay, so that means that this right here, therefore, that point is 4, 9. That's what I need. Now, the slope at 4 is already given to me. That's actually what I just found right here. So the slope is equal to g prime of 4, which is equal to f of 4, which is equal to 3. Okay? So that's pretty simple. That's all I have. So the formula for the equation of a line, the equation of a line formula, it says y minus y1 is equal to the slope x minus x1. Okay, so that is that. Now, so far so good. Now, where it gets a little strange is right here. It says, at what x does g of x have an absolute minimum or maximum? Now, if you remember that g of x has max or min, and this is something from last semester that we talked about, has a maximum or minimum at the critical points or the endpoints. Okay, now on this one, well, let me just get to that problem, then I'll tell you why this is going to be a little bit strange. Okay, so on this one right here, we're going to try to find the critical points. So we're trying to figure out if the derivative of g at x is equal to 0. Okay, so here's where it's weird. Okay, now I know that I told you many times that we're basically looking at f of t. Remember that g prime of x is the same thing as f of t or f of t is equal to 0, okay, or whatever that is. So I'm trying to figure out, I mean, this one's not too bad. I mean, you can see that right here, right? F of t is equal to 0. It's right here on that point. I hope you can see my hand right there. So right there, x is equal to 1. Okay, so now the other stuff that we have to check. All right, now that's about it, though. That's the only place that is 0 right there. That's the only place that we have a 0. So the next thing we have to do is have to check the critical points. Okay. Now we're gonna kind of ignore the peaks here because you have some peaks here, but we're gonna ignore that for now. So we have the absolute. Let's see. We have to check all the points. So we have g of negative 3. I'm sorry, which we found from the first example was 9/2, and then we also have to check g of 1. All right. So kind of the pain in the butt part of this is that I have to check each point. Now g of 1 is the integral between 2 and 1 of f of t dt, which means, because that number is smaller than that one, that my upper bound is smaller than my lower bound, I have to rewrite it like this. Right, which means I'm going to have to find the area under the curve. Now, I already did the work ahead of time, so I'm going to go ahead and assume you sort of know what you're doing here. So we have 1/2, 1 times 3, and that's equal to negative 3 over 2. Let me check it out here on my own. See, 1 and 2. Yeah, that's a pretty simple one. So we got negative 3 over 2 And finally, we have to check the other endpoint. Now, the other endpoint is going to be 5, g of 5. So same thing, we're gonna figure out this triangle. Let's see, between 2 and 5. Didn't we already find that somewhere? Am I wrong? Yes, I am wrong because I can't see it anywhere. Let's see, 2. Oh yeah, no, we have not found that. Okay, so we have a triangle and a trapezoid. Let's see, 4 and 6. 2 and 5. Okay. Alright, give me just a second. Getting a little bit lost. Well, I'm just going to go with my notes here. I don't really know. Let's see, 1 and 3. Oh, I see what I did. Okay, yeah. Yeah, never mind. I pretend that was a big triangle and I subtracted. Okay, so then basically what I did here is I took the area of this whole triangle here, then I subtracted this little sliver right here. So that's what I did. That's why I have a minus here. Okay, so that is going to give me 21/2. So basically, to find my absolute minimum or maximum, I'm just looking for the highest y value for my max and my lowest y value for my min. Now, let's see, we have at 5, 21/2, that's 10.5. And this is my min. Okay, so I'm going to write here, final answer is going to be my absolute max is at x is equal to 5, and my absolute min is at x is equal to 1. Now, on this one, the point of inflection, if you remember, that means where the second derivative is equal to 0, right? So we're looking for the derivative of f, and that has to be equal to 0. Now, here's where I have to kind of, I wouldn't say retract, but let's not lose our focus. On this one, the second, if you look at it, there's nowhere on here, all right? Basically, I'm looking at the derivative of this. If I were to take the derivative of this function, basically I'm looking for where on this is the slope of anywhere on here, 0. Now, we have a sharp peak here and we have a sharp peak here, all right? Which means if I take the derivative of that, the derivative does not exist at those 2 points for that graph. Okay, so I know that. Now, what I'm going to have to write though, for at least for this lesson, all right, so again, this is not usual, but because I'm trying to concentrate on the geometric figures of this, I am going to say that my points of inflection are at 0 and 3, which I know normally those would be undefined, all right, they would not exist. However, because otherwise I actually have to take I'm just focusing on something other than this. Okay, so again, I understand that you cannot take the derivative. The slope here normally is not 0. All right, it's undefined. I get that. Okay, but I'm gonna pretend like it is kind of curved at the top, like at the very top it's a little bit curved, and we have where. Right, we have a sign change where the second derivative, or f prime of x, has a sign change. And again, I know it's a sharp point. So normally we cannot take the derivative of that. However, we're going to go ahead and say that sharp point is a little bit curved at the end. All right, just for the sake of today's lesson. right? Hopefully, if you got any questions, make sure to go over the video again, and tweet at me if you got questions. And I guess we'll talk to you tomorrow.